Hi, how are you today? At this point, we will evaluate the breeding practices and management in swine. According to Philippine Council for Agriculture, Aquatic and Natural Resources Research and Development, swine production in the Philippines is a 191 billion peso industry and is the largest among the livestock and poultry industries of the country. The Philippine swine industry is ranked 8th in the world in terms of the volume of pork production and number of breeding sows. Despite being dynamic and technologically advanced, the local pig industry is still confronted with inefficiency of production due to low sow productivity. Thus, the Philippine Council for Agriculture, Aquatic and Natural Resources Research and Development of the Department of Science and Technology supported research and development initiative to improve the productivity of the Philippine swine industry. And one of the breeding strategies that is being applied is the genomic selection. The application of gene marker was developed by the Philippine Carabao Center and the Bureau of Animal Industry in partnership with the accredited Swine Breeders Association of the Philippines. 16 gene marker protocols associated to highly resized, fast growth rate, and meat qualities, as well as 7 markers for screening of genetic defects and disease resistance were optimized. The adoption of the gene marker technology by the swine breeders farms is expected to increase productivity and efficiency in terms of the number of pigs weaned and live weight produced per sow per year. The application of gene markers that are associated to economically important traits has resulted in significant improvement in the number of pigs produced and consequently the hog live weight produced per sow per year. In addition, gene marker assisted selection also facilitates genetic improvement in terms of productivity and production efficiency, meat quality, disease resistance, and in screening against genetic defects in swine breeding herds.
Noong pong wala pang genomics study, meron po tayong target sa industry na production ng mga inahin. For example, yung piglet per sow per year, nasa 16 to 18 lang tayo. Tina-target ng gobyerno na makarating tayo sa 22 piglet per sow per year by year 2020. Isa yun na parang gusto nating ma-achieve. And then, meron tayong mga mortality rate sa mga baboy na I think mga more than 10% currently. Hinahanap natin ngayon yung mga disease-resistant gene para yung mortality rate ay mapababa natin. Our target is 5% after the genomics project.
Based on our project on swine genomics, this is a process of breeding and selection of swine wherein we use DNA or molecular markers as among the tools that is used in the selection of outstanding individuals within a breed. But then, we use the DNA as among the tools of selection that we are using now to continuously improve the production performance of our pigs.
Swine Genomics is the project by the DOCP card and it's the use of DNA biotechnology in gene marker selection method in increasing production efficiency and productivity.
Actually, itong Swine Genomics project na to is a concrete example nung tinatawag nating public-private partnership. Kasi dito sa proyektong ito, napakita talaga yung DOSTP card ay nag-put up na isang proyekto in partnership with the private, which is the Accredited Swine Breeder Farm Association, and also with the research institution like the Philippine Carabao Center, na sila yung nag-develop, yung PCC yung nag-develop ng technology, sila yung nag-optimize ng mga laboratory protocols, then Picard give the R&D funds. Then ang BAI also supported us for the linking of the technology or the project to the private. Nag-participate sila dito sa ating project by providing the needed blood samples. Participation of the private sector, the laboratory protocols will not be optimized kasi walang blood samples. Plus, yung guidance ba ng private sector in the process of developing the technology.
The Swine Genomics project was conceptualized and implemented for us to develop the skills and also develop the facility to allow or to enable our swine industry to make use of the technology or the molecular technology in the production of swine. We want to increase productivity and efficiency of swine production. And at the moment, this is one of the tools that we see to be efficient or that would lead us towards improving efficiency and productivity of our swine. Purposely, to be able to compete in the business of swine production.
Ang swine genomics po kung tutusin ay isang bago sa pakinig ng mga swine breeder po ngayon. Ang malaking advantage po kung naka-genomic technology ang baboy mo, hindi mo na kailangan mag-forecast kung ilan po ang kailangan na dami ng halimbawa sa anak. Ngayon po, sa ngayon po kasi ang performance ng Pilipinas ay nasa 20 piglet per sow per year. Ngayon, nung nag-genomic po kami, na-attend po namin yung 28 to 30 piglet per sow per year. Halimbawa po ngayon, ang kasalukuyan, kung ang baboy po ay 150 kilos, sa kasalukuyang merkado, ang inaabot lamang po ay nasa mga 75 to 80. Kung naka-genomic technology ka, ang baboy mo may posibilidad po na umabot po ito ng mga 95 to 100 sa loob ng 150 days lamang. So malaki po ang magpagkakaiba.
Gene marking is the concept of selecting breeders or future breeders in a swine population or a swine breeding unit for improvement of the efficiency and productivity of the operation. And gene marking is the method of establishing what different genetic traits had to be used in the gene marker selection method.
Initially, ang ginawa natin doon sa Genomics project, nangongolekta tayo ng blood sample, then isasubject ito sa DNA testing para makita yung markers. Meron tayong mga positive trait na identify. From there, yung mga hayop na still na nabubuhay pa ngayon, i-match natin dun sa, for example, yung babae na nabubuhay pa sa ngayon, kukuha tayo ng barako na nabubuhay pa din, i-match natin yun dun sa babae. Para makaproduce tayo ng target natin na genes. Parang, halimbawa, nakakita tayo ng inahin na mabilis maraming mga anak, tapos meron tayong barako na carrier din na maraming mga anak. Pagsasamahin natin yun to produce yung desired animal natin na magiging future breeders na siya naman yung magpapamana na ngayon ng magagandang lahi, yung genetics.
We have established yung Swine Genetic Analytical Service Laboratory dito nga sa Bureau of Animal Industry. So yung laboratory natin is capable of testing the genetic traits related to sow productivity. So for litter size, for example, so we have 3 markers associated to litter size. One is the estrogen receptor gene, the other one is the LIF gene, and the other one is the prolactin gene. So all of these 3 markers are associated to high litter size. So meron tayong na-optimize na rin or available gene markers for marbling, and meron din tayo for growth rate. So meron tayo yung tinatawag nating myogenin gene. So itong marker na to is associated for fast growth ng ating mga baboy. So meron din tayong 3 genetic markers that were optimized on finding genetic defects. So ito yung mga markers na ayaw natin makikita natin doon sa ating mga breeders kasi genetic defects nga ito. So negative traits ito kumbaga. So tatlo ito, so it includes yung ating PSS or porcine stress syndrome. The other one is the acid meat or the RN gene, and the third one is the Box gene. The Box gene is related to scrotal hernia. So itong mga traits na to, itong mga genes na to, ayaw natin to na maging present doon sa ating mga breeders. And lastly, for the disease resistance, meron din tayong mga genetic markers for disease resistance, particularly on the resistance to E. coli disease or E. coli pathogen. Also on influenza virus, we have also gene markers on that. Then against salmonella, we also have gene markers on detecting resistance to salmonella. And then lastly, the resistance to intracellular pathogens. So we have 4 gene markers that we can use to detect the disease resistance of our breeder pigs.
Actually, wala naman tayong ina-alter eh. We're trying to influence the product. Parang may dalawang baboy na carrier, for example, ng positive trait, yung lalaki, carrier yung ng positive trait yung babae. Pag pinagsama mo, wala ka namang in-alter, di ba? Hindi naman tayo nag-i-splice ng genetics. Wala tayong binago. We just try to influence the end product. Parang, pag pinagsama mo to, alam mo yung result. Yun lang naman ang gusto nating mangyari. Wala pa naman tayong genetic engineering na ginawa. We're not violating yung mga GMO na sinasabi natin. Wala tayong ganun.
Pag nakuha na natin yung information, yung genetic information, binabalik po yun natin doon sa may-ari ng baboy, doon sa breeder farm. To be used, for them to be used as guide in their selection process. Kahit hindi pa nanganganak yung baboy, pwede na nilang masabi na itong baboy na ito ay mataas ang probability, mataas ang chance na magbigay siya ng maraming anak because they carry this gene. Another advantage is, traditionally, napipili lang natin yung high litter size on the female. Kasi yung babae lang naman yung nanganganak. Yung lalaki, hindi naman siya nanganganak. But with molecular selection, pwede na rin nating mapipili yung barako o yung lalaki na carrier din ng gene for high litter size. We must remember that the male contributes 50% of genetic complement or the genetic character of an individual. So, in the swine production, wherein breeding and swine production itself in the Philippines has achieved certain level of sophistication already, mayroon na kasi tayong mga breeds na pre-identified na sila to be sow-line breeds and boar-line.
Yung mga swine farmer na hindi naka-adapt sa genomic technology, mahihirapan silang makasurvive. Like for example, kasi ngayon, sa ibang bansa, nasa 30 piglets per sow per year sila. Ang performance ng Pilipinas nasa 20. Kung titingnan mo ang cost to produce, mas mura yung kanila, kaya nga mura yung imported meat. Yun po yung magiging isang bentahe ng naka-genomic. Pag naka-genomic ka, unang-una, mas mura yung cost to produce mo. Pagdating po sa, halimbawa, sa piglet. Halimbawa, sir, sa 20 piglets ang pinuproduce ng isang baboy sa Pilipinas, sa average performance ng Pilipinas, kung ang babasihan mo ay 1,500 ang cost per piglet niya pag lumabas, so 30,000 na yon. Kung na under genomic ka, may possibility na nagpo-produce ka ng 30 piglet per sow per year. So 30 versus 20. Kung 30,000 yung puhunan mo, 30 divided by 30, nasa 1,000 ka lang. Ibig sabihin, pagka hindi ka naka-genomic, nasa 1,500 ang cost mo per piglet. Samantalang pag na-under genomic ka, nasa 1,000. So malaking diferensya.
Among breeder farms, if we talk about the accredited, because the Philippines has its accreditation program for swine breeder farms. The program is being hosted and managed by the Bureau of Animal Industry, which is also being participated by the PICARDI OST as its R&D or science and technology partner with other colleges and universities, UPLB, CLSU, to mention a few. It's a multi-agency group that manages or that implements the Swine Breeder Farm Accreditation Program. Now, popularity of swine genomics, if we are referring to the members or the accredited swine breeder farms, I would say it's already popular because all of them are already aware of the program, are aware of the technology, and all of them have already expressed their interest to submit samples and have their breeder pigs genotyped.
As you have noticed in the video, the research on swine genomic is supported by the UST to increasing production efficiency and productivity and to be more competitive. Genomic selection method increased piglets based on the UST report. This method has been done in reliable laboratory that capable of testing the genetic traits related to sow productivity. They optimized 3 markers associated to high litter size, such as estrogen receptor gene, prolactin gene, and leukemia inhibitory factor gene. There is also a gene that was optimized that associated to fast growth of swine, such as myogenin gene. In terms of the genetic defects, there were also 3 optimized gene markers on finding genetic defects, such as porcine stress, syndrome gene, acid meat gene, and scleral ulna gene. There are also genes that were developed for the swine to be resistant from E. coli, influenza virus, salmonella, and intracellular pathogens. The UST reported that all of these gene markers contributed to the increase of hog production, particularly in San Jose, Nueva Ecija.